Good evening to everybody, and welcome to the 6th Sheffield IoT Meetup and our third event fully online. My name is Mark Davies. I'm the CEO of Ioetec. We're a cybersecurity specialist in IoT data security based here in Sheffield, and I'll be hosting the next 90 or so minutes. Now, we set up Sheffield IoT Meetup to build an IoT ecosystem that enables individuals, organisations and interested parties to share their capability and stimulate conversations and collaborations. And we hope to bring together parties to enable real-world IoT applications to happen through facilitating technology, research and development and commercial partnerships. We like to help position Digital Sheffield as a leading IoT centre and lay the groundwork for larger events, hopefully not so much online, but in the not too distant future, I hope, in a more friendlier face-to-face atmosphere that reinforces this reputation. Now, this wouldn't be possible without our sponsors, Pitch-In of the University of Sheffield, and specifically I'd like to thank Kerry, Fern and Bryony who fit the organisation of this event into their busy schedules to actually make it happen. I can't take any credit for that. They'll be in the background as moderators, ensuring everything runs as smoothly as possible. Now, it's great to see so many of you returning from our previous events and welcoming a lot of new names and online viewers, which is one of the benefits of these virtual events, where we can attract a much greater spread of an audience geographically across the UK. So welcome to those new people who've joined us. Now, the theme tonight is IoT innovation, and we have representatives of both ends of that spectrum. With Jonathan Bray, a very highly experienced Deputy Head of Digital at the AMRC, Kevin Hallis of KTN, who will go into depth behind their activities in helping manufacturers and innovators co-create future digital stuff for industry and manufacturing, and Tom McAllister of K-Burn Solutions, who will relate his first-hand cold-face experiences of getting solutions implemented in the field. We have a new addition to our usual programme. The University of Sheffield is setting up a LoRaWAN network in the South Yorkshire region. They've sponsored a student placement summer programme for a number of undergrads who are starting their IoT journey and have been developing some IoT prototypes and code of their own designs and making use of this soon-to-be city-wide LoRaWAN network. Dr. Ramsay Taylor, one of the university's teachers in the Department of Computer Science, and who is also the lead supervisor of this pitch-in programme, will introduce them. We have 9 of them conducting a lightning pitch of their projects, punctuating each of the key speakers throughout this evening's webcast. Now, if there's any questions throughout this webcast or you'd like to pose one of the speakers, please use the chat facility and I'll pose them at the end of each section. With time permitting, I'll also host a 5-10 minute towards the end of the session for anyone wishing to shout out about their relevant IoT activity, events and interests. Finally, I'm sure we've all become accustomed to the technical glitches that occasionally occur on these live webcasts, so please bear with us should we encounter any, and we're rectified as soon as we possibly can. So now, without any further ado, I hand you over to our first speaker, who's going to be Ramsay Taylor, who will introduce the first 3 of our LoRaWAN project undergraduates. So over to you, Ramsay.
Hi, Mark. Thanks for that. Yeah, I was going to kind of introduce the whole project for 30 seconds first, just for anyone that doesn't know about it. Yeah, so I mean, we actually got funding for Pitch-In for this, and we're very grateful to them. We've got 11 student placements going on over the course of the summer. This was all planned kind of months and months ago. Many of you know Steve Jubb, who's probably on here somewhere. He's been rolling out LoRaWAN infrastructure all over South Yorkshire. And we were very keen to get some sort of showcased items and products working through it to give everyone an idea of what can be done. I was particularly keen because I'm familiar with lots of people that have great idea for IoT projects, but they maybe either they don't have a technical background to do that initial setup stuff, or maybe they're just in a position where they haven't got the kind of couple of months that we all know it takes to build a thing, see it fail, fix it, debug it, build another one, see that fail, and get through that kind of basic sorting things out and getting things working side. So, I mean, our students are going to present today, and they've all got really interesting ideas for projects, some of which may even turn into products, but I'm less interested in whether they produce ideal products at the end of it. What I want them to have done is gone through all of the kind of boring bit of getting the network working, getting some code together and getting some prototypes built. because that's then really a springboard for other people to build off. So all of the code they're producing is going to be freely available on GitHub at the end of this. Lots of their design documents will be available. So anyone that's got brilliant IoT ideas that can use LoRaWAN should be able to start with some of their work and have that basic stuff done for them. I wanted to apologize on their behalf because, of course, when we planned this, the idea was all of the students would be sat in the university using the electronics lab to build things, using the computer labs and all of that. Of course, COVID's kind of put paid to that. That coupled with some exciting university bureaucracy means they might be a little bit vague about exactly what they've built at this stage, because we're still working through getting kind of hardware out to all of them. They'll introduce themselves in a minute, but we've got students actually now spread all over the world. I mean, one of them's calling in from Canada, one of them's probably calling in from Egypt last time he was seen. So they've done a sterling job anyway of just keeping this working despite the circumstances. So we've got 11 students, but 2 of them are paired up. So we've got 9 presentations for you this evening. We've kind of grouped them into 3 so you can get a short burst and then have a bit of something else. And I think Mark said if we give them 2 minutes each to present their little section, and then we'll have questions at the end of the group of 3, if that's all right with everyone. So because one of our speakers is doing healthcare-y things, our first 3 are sort of health-related ones. And hopefully somewhere on the call is Moana, who's going to do the first presentation. We did change the running order about 3 hours ago, so hopefully she's ready.
Hello, can you hear me?
Yes, we can. Go for it.
Oh, good afternoon, everyone. Okay, so good evening. My name is Moana Tucker, and I've just finished my 3rd year of aerospace engineering at the university. And my project is looking at indoor and outdoor air quality monitoring. So my project involved working with the Digital Media Centre, or DMC, in Barnsley. The DMC is a relatively new building that has an airflow system that utilises external air surrounding the building. My project has been looking into internal and external air quality and seeing how much of the pollution outside the building is brought inside through this system. The plan is to have 2 sensors, one inside and one outside, taking readings in the same way, so that you'd be able to accurately compare the 2. So far, I've investigated how air quality can be measured, and I've linked up modular temperature, humidity, and air quality sensors to an Arduino board. Since air quality is defined by looking at different gases and particulate matter, I've measured both of these inside and outside of my own house. So when I was looking at the data, I saw that there were spikes in particulate matter detected when there was movement around the air quality sensor. So as a side, I've started to write the Python code that processes the data and looks at how these factors can be used to indicate room occupancy. I thought that this could be potentially useful in times of COVID because it could suggest adherence to social distancing, particularly when you're in small spaces. So in terms of next steps, I've worked on the beginning and end of my project, but now I need to work on the middle and possibly the most important part, which is to work on connectivity and linking up to the Things network so that my sensors are transmitting wirelessly. So thank you for listening. If you have any questions, suggestions, or if you know of any common mistakes made in this sort of area, please don't hesitate to let me know. Thank you.
Thanks for that, Moana. Yeah, so people with questions or people that want to follow up with the students, you're more than welcome to get in touch with them at the end of this. We'll crash on to the next one, which should be our long-distance correspondent from the frozen north. Seth, are you there somewhere?
Yes, I am. Hello, everyone. So my idea was to collect data using the IoT and LoRaWAN network in partnership with bicycles. So as I'm sure everyone knows, that cycling is a fast, healthy, and green method of travel and will become more and more important as communities like Sheffield become more and more green and want to improve the fitness of people. I believe that technology can be used for data that can hopefully guide public policy decisions made around infrastructure and traffic and air pollution on our roads, and try and break down some of the barriers that many people feel that stop them from taking up cycling as a day-to-day commute sort of thing. And so pretty much my idea is to have a device that will measure the acceleration of the bike, its GPS position, and the air quality it can sense around it. And then this data can be visualized. So I've set up the back end, like the server side of things, because I haven't actually built anything because I don't have any of the the kit yet, unfortunately. But so if you can see here, the bottom one is data taken from Urban Flows Observatory in Sheffield and put into a Grafana and InfluxDB database. And the top one is using Flux and Grafana again, but this is just a randomly generated path that a bike might travel on, just for Python code that uplinks various GPS coordinates. And so this has also been proven to be effective in other countries. In the Netherlands, they have this sniffer bike project, which does a very similar thing to my one. I didn't know about it when I was coming up with my idea, but it too tracks the position and air quality of bikes in the air around them. But this one uses LTE rather than LoRaWAN, which is a more energy inefficient method of communication. I believe LoRaWAN will work better for it. So hopefully, as I move on throughout the next month or so, I'll be able to have the kit ready and attach something to my bike and see how it works and try and get a prototype developed.
Cool, thanks for that. There's questions already, but we'll get the third one in before we come back to that, if that's all right, Phil. So it's Mark Harris, I think, is our third correspondent. Where are you?
Just give me a share video. Hello everybody, my name is Mark. I'm a mechanical engineering student going into my 4th year in September, and I've been looking at the applications of IoT in a medical context, specifically creating a wireless non-invasive heart rate monitor that can be used for diagnostics and diagnosing things such as atrial fibrillation, as you can see in the slide there. So far I've got a way of handling the data and code that will analyze any incoming data from this heart rate sensor. Sadly, due to a lack of hardware, I haven't got the sensor built yet, but what I've learned in researching such a system is that the design of the sensor has to be incredibly robust and be able to deal with knocks or movement, because obviously they can skew the data, and in order to combat this, we'd need to include an accelerometer, so look at the accelerometer data versus what's been produced by the heart rate sensor and say, okay, yeah, if the data's gone weird because it's been moving around a lot. Security is also an incredibly important aspect, and I was speaking to Mike Fox about security. The Things Network rather unhelpfully says that their LoRaWAN system is secure as long as you do it correctly, but doesn't give you any steer then as to how to do that correctly. So I've been speaking to Mike about that, and beyond sort of further applications of this is using machine learning to identify whether the patient has got atrial fibrillation. That's a little bit beyond my remit. I'm not a computer scientist, but it would be possible to integrate a system that would pick up abnormalities within the heart rate sensor on smaller data sets, I should say. That's the long and short of it really for my project. If anyone's got any questions, feel free to
thanks for that.
shoot them my way.
Mark Davies, did you want to pose the questions to save us having a free for all?
Yeah, absolutely. Thanks, Ramsay, and thanks to those 3 students going through an update on their project. Yeah, got a question from Phil Hornby saying, what volume, this is for Seth, at what volume of cycle traffic do these sort of systems become viable from a coverage perspective?
I'm not too sure about the coverage of the city, to be honest. I'm not sure how many gateways you'd need. I know LoRa is pretty good for long-range detection and can be used in cities pretty well without scattering of the signal. And I'm not sure a number of bikes. All right. I mean, the one in Holland, which I'm pretty sure someone said, they have a lot of cyclists. This I just started out as a small startup. I'm pretty sure they gave it to like 10 people, and they were really avid cyclists or something, so they tracked thousands of kilometers. So I think it's as the data is made available. Obviously, the more bicycles you have, it's better. But you can just map it with a couple who are really spirited about cycling.
Okay, and Abdul follows on question. What sort of server technology are you using?
I'm using InfluxDB to store the data as a time series data, and I'm using Grafana to display it.
Okay, great. Thanks, Seth. And I guess a question to all three of them is what's been, it's been quite a challenging time with not being able to sit face to face in the conference rooms in the Diamond building, but and not getting the kit as well must be incredibly frustrating trying to do this. But how are you sort of overcoming some of these problems? Are you sort of doing workarounds and just creating your kit at home? How's that working?
I mean, I can answer for myself, but I've been doing the things that I can do. So obviously, if I was to do it with the kit in front of me, I'd probably try and develop the kit before I developed the server end of things, but I've had to do it in reverse. And now I am spending my time documenting things, which again is probably the last thing I'd want to do. So I'm filling my time with things I can do.
Yeah. So much the same as Seth for me as well. We've just been kind of working on the software side of things and just working with the hardware that I've got in the house, basically.
Okay.
Likewise with me, just working on the coding side of things, because that's not particularly my strength. I've done sensor design in a factory before, so I'm fairly familiar with the hardware, but the software is something I've had to learn. So it's almost forced me to really focus on that, and I've got something now that works, so I'm kind of pleased with that.
Okay, great. All right, well, thanks everybody for that. We're going to see the next three students presenting that after our next presenter, and hopefully Tom will be lining up his slides. So if I can invite Tom McAllister, he's from K-Burn Solutions, and he'd be looking at the challenges that he's faced scaling up IoT solutions in the integrated health and care sector. So Tom, are you there?
Oh. Yes, I'm here. Hello? Oh, yes, can you hear me?
That's good. That's good, Tom. Thank you.
Right, great. Thanks. Yeah, Tom McAllister. I'm a director with K-Burn Solutions. Can I say it's really interesting to hear the students presenting those projects, because it kind of makes me realize that maybe as a business we're going down the correct road for once. This is basically what we do. We do smart IoT connectivity, gateway sensors and management systems. And as you'll see, we do a lot of what the students are already looking at, although we're not using LoRaWAN. We're using mobile communications. I put this slide in because obviously it's about, I wanted to talk about health and social care integration, and this slide really is a project that we've been doing in Scotland, which shows you the challenge in terms of integration, because from an IoT perspective, we collect data, and we collect data from sensors in people's homes, medical devices, environmental sensors, and access control and attendance management sensors. All of that data, then the requirement is that it has to go to a number of different organizations, and that's a huge challenge. In terms of scaling up, we have run proof of concepts. We currently have a proof of concept underway in Spain on the care side. We've worked with the NHS in Scotland. The really interesting thing is, much as people say that there's integrated health and social care, the number of organizations that are truly integrated from a health and social care perspective are not that many. Some organizations have managed to achieve a certain amount of integration, so finding integrated health and social care organizations is a challenge. I think the next thing, investment requirement for volume. We've run a number of proofs of concept, and I'd say we're running one in Spain at the moment. and we've got one in Scotland. In terms of investment for a startup business in this area, when somebody comes and asks you to roll out 1,000 gateways and sensors, which is potentially what will happen for us next year, you have to have already sorted out and found an investment requirement for that equipment, because it's the equipment cost that is the issue, not the development. In terms of field trials, getting data from field trials that are large enough to then justify a business case and budget approval. Again, across integrated health and social care, that's a bit of a challenge, quite frankly, because getting the right data, which is, I suppose, focused on what you're trying to achieve. So in a health perspective, we've been working on basically delayed discharge days. But from a social care point of view, they're looking at maintaining people in their home safely. So quite a variety of data needed to actually make a business case. Standards and approvals, again, from an integrated health and care perspective, there are the two main sort of standards in terms of organisations. You've got the existing Telecare Services Association, who are responsible for standards in telecare, which is related to social care. And then also you've got the medical device regulations, which are on the health side, which you need to have your whole system approved by MHRA. For those of you who are aware, there is a thing called COVID-19, where there is a little bit, I think, at the moment of riding a coach and horses through some of the MDR standards to get monitoring out there quickly. One of the students already mentioned about AI, because as you've seen from the previous slide, we're sucking in large amounts of data. How you then relate the different pieces of data across the different stakeholders to actually provide proper analysis. Again, in terms of scaling that up, we have a couple of large IT service providers that we're working with, and we're basically letting them take on the challenge of AI, because our interest is in managing gateways and sensors and large volumes of those. We are not experts in any way, shape or form in terms of AI and managing large volumes of data. Integration with a wide range of disparate social care and NHS systems. Anybody who's got any experience of social care and NHS, especially, actually I will say Scotland's easier. Some people would say that, and I would say that, but we have a much reduced number of systems to deal with compared to England and Wales. Another challenge in terms of scaling up is, and again, probably one of the reasons why we haven't progressed the next stage of our proof of concept up here in Scotland, is basically the availability of NHS and social care staff to actually roll out a larger scale trial or a larger scale project. Building service and support capability, again, a bit like the AI, we are outsourcing the service and support capability to the IT service providers that we're dealing with. GDPR and privacy impact assessment, we've been involved in this with the NHS in Scotland, and that is quite a large task in terms of IoT. Oh, honestly, I never touched her. All right, sorry. Management of IoT gateways, sensors, and medical devices remotely. If you have 1,000 gateways out there, you can't very well ring patients or people with care needs to tell them to switch them off, switch them on again. So there's a large amount of the effort that we've put in is actually around management of gateways, sensors and medical devices remotely so that we can keep the service running. Reliable communication service. We are very fortunate in that our parent company is a mobile communications company. So we have the ability to and the knowledge to actually manage the communications, which is GSM, 3G, 4G in our gateways. And finally, big part of my job is building channels to market. So from that point of view, we have quite a wide range, just not care and health. We also do indoor air quality monitoring, funny enough. And just recently we're doing remote monitoring of fridges from the point of view of pharmacy. So finding the right channels to market and people who can support you and take your product out there when you're a small company is a major challenge. So basically we do environmental monitoring, home monitoring, alarm systems, school. Our target markets are, in terms of environmental monitoring, we're very much looking at the market from a channel point of view, being companies who work in that space, such as building companies, building preservation companies. Home monitoring, obviously housing associations, alarm systems similarly. Schools and universities from an air quality point of view. Office, retail and commercial properties, again, are an opportunity for air quality monitoring. Caravans and holiday homes, basically monitoring those in terms of air quality, vulnerable persons. Obviously, we can monitor people remotely in terms of their movement. And then housing associations, care facilities, assisted living, and health and telecare is all about integrated health and care. For those of you who are of that kind of bent, there is actually some schematics on the slide. I don't know how our marketing person managed to work that out, but there we are. So that's me. That's me finished. I think just about 10 minutes. So happy to take any questions.
Great, thank you, Tom. Yeah, there's a couple of questions there lined up. I think you've answered the where the sectors are that you've taken up, but Kerry asks, what sectors have you tried amongst those in the list there on that final slide? Where's the uptake been easiest for you to get traction?
Sorry, in terms of market sectors?
Yeah.
We're basically on the care side, in terms of monitoring people from a movement point of view within their homes, monitoring people in terms of their nutrition. So we can monitor when kettles are on, fridges are opened and shut, microwaves, ovens, all the sort of stuff that is based around nutrition, and also then access. So we have a partner who can actually do geofencing and mobile monitoring of people when they're out and about, using what is basically a mobile lone worker device.
And Sarah asks, do the business case concerns and issues post-implementation challenges, includes post-implementation challenges such as training, support, maintenance, the lifespan of the device, so all of sort of aftercare before it needs replacing. What about the data management transfer when these devices are upgraded?
In terms of the data management when the device is upgraded, well, we actually have backward integration with all the devices that we use. So in terms of the data transfer, the biggest challenge in terms of data is the distribution of it, to be honest, Mark. Because you have a number, as you saw in the earlier slide, a number of organizations who are interested in that data. So that distribution is quite important. At the moment, we distribute the data using MQTT, which for those of you who are in the IoT space is pretty much a standard protocol, where we publish the data, and then from a secure point of view, we can get people to subscribe to that data. Our focus has been on managing a lot of devices remotely. We haven't been so focused on managing the data, because we are actually passing that data to organizations who actually have the expertise to analyze it and make more sense from it.
Okay, and Abdul asks, are you using overlapping gateways to mitigate against the faults?
No, we aren't. No, but we actually can and do get regular messages, so a heartbeat from the gateway, so that we actually know the gateway is active.
Right. Okay.
If anybody wants a full presentation on device management, they can get in touch.
Okay, I'll send Abdul your way. What about, so what are you doing with regards or your reaction to the COVID-19 situation then?
Yeah, that's been an interesting opportunity for us. We're working with a partner in the Philippines. Philippines have done a slightly different approach to quarantining people coming back into the islands, which is actually they have rented or booked hotel rooms in hotels that currently aren't being used. And what they want to do is they want to be able to monitor the people within the hotel room. What we've done there is we have a proposal sitting with the Bureau of Quarantine in the Philippines, which actually allows us to monitor, one, movement in the hotel room, two, people's pulse oxygen level using a pulse oximeter to the gateway, and also their temperature using an in-ear thermometer that then transfers the data. So we basically capture motion, body temperature, and pulse oxygen level, which are, from a medical point of view, key indicators that somebody may have got COVID and require testing.
And are you managing to get any kind of traction in the UK? If we're going to start isolating for 10 days, particularly those people coming back from Spain, can you get any traction and going in commercially into the UK at all on that score?
Yeah, well, we have a large IT service partner who are currently talking to the Scottish Government about that. They're talking to the Scottish Government about the quarantine monitoring and whether the technology that we've developed for the Philippines is a possibility. However, obviously, it's a slightly different situation, Mark, that we're not really, I suppose, ring fencing people in a hotel room here. They're being monitored at home, yeah. So it's a slightly different situation. It's less easy to convince people and the Scottish Government to put this stuff in people's homes when they may not need it for an extended period of time. Where we are getting some interest is in the monitoring of pharmacy fridges for vaccines, because when you think about the scale of the vaccination program that's going to be rolled out very soon, both for flu and for COVID, there's only a certain amount of capacity in GP surgeries and health centres for storing vaccines currently. So there is an anticipation that actually what will happen is they will need to buy more fridges to store more vaccine.
Sure.
And vaccines are sensitive between 2 and 8 degrees centigrade.
Yeah, sure. And Phil asks, are you reporting that data to the cloud, or are you processing it out on the edge? It goes back to what you said earlier on about your concern about shifting the data around, but there's a vast volume of data. So are you looking, or is there a move towards pushing that processing out towards the sensor or the gateway itself rather than it being in the clouds? Where do you sit on that?
At the moment, we're using Azure and storing the data on servers in the cloud there. at the moment. Whether we do that on an extended period is still up for grabs security-wise. We haven't implemented all the security that is possible on the gateway, and that's because we haven't needed to be honest, Mark. But it's certainly something. The project that we're working on in Spain is a joint European-Japan project called MSEC, which is all about IoT security. And as I say, we're working with a partner in Spain who are part of that program. So to a certain extent, they are investigating our technology to see how we can best make it secure.
Okay, so that's at the gateway. What about from the sensors to the gateway then? Is that being secured, asks Abdul?
No. Well, we're using Zigbee as a radio transmission. But as far as I'm aware, that Zigbee isn't encrypted data. But I need, to be honest, Matt, I need to refer to my technical guy. He'd probably be on this squirming.
I'm not being technical myself, but maybe we need to take that conversation offline and have that conversation with Ioetec as well.
Yeah.
All right, Tom, thanks ever so much for that. I appreciate it. And anybody who does want to follow up with Tom, we can certainly furnish you with his contact details. I'm sure Tom wouldn't mind.
I don't mind that. I'll need to drop off as well, Mark, so if that's okay.
Yeah, thank you, Tom.
Yeah, okay, Mark and Kerry. Thank you.
Cheers now. Okay, that's a great insight into how difficult it is of actually trying to scale up IoT in the real world, which does seem to feature a lot amongst the white papers that I read frequently about the difficulty of going from a trial into a full-blown adoption of IoT, scalability, and Tom certainly seems to have come across those issues. So we're going to move now on to our second segment then with our IoT student placements. So Ramsay, if I can hand over to you.
Yeah, absolutely. So we've got 3 more. I'm not really sure if there's a simple summary of the next 3 as a theme. I guess they're all about tracking stuff moving about. So Tom Edwards, are you on? I think you're up next.
Hello. Can you hear me okay?
Yeah, go for it.
Awesome. So thanks a lot for having me, everyone. My name's Thomas Edwards. I've just finished my 3rd year doing digital electronics. So when I first started this project, I was really interested in the idea of indoor geolocation, like looking at specifically factory and production environments. So I sort of took those ideas and started researching technologies, and one that stood out to me was Bluetooth Low Energy and how it sort of synergizes with using LoRaWAN, as both is quite low power technology, so you can create devices and systems that can last on batteries for months and even years. So I sort of took that idea of wanting to do geolocation using LoRaWAN and Bluetooth to Alex Kelly from Tinsley Bridge, which is a steelworks factory. And he came up with the idea of using that technology for asset security. So at Tinsley Bridge, they have a work area, and they've got quite a valuable tool used for inspections that's meant to be kept in a locked locker, taken and used on a workbench in this work area, and then returned to that locker. However, sometimes it can go missing, and not knowing where it is can lead to delays in production. So to solve the issue, the plan is to use a Bluetooth beacon attached to that tool that is transmitting a advertising packet every 2 seconds, and then have receivers strategically placed around that work area so you can know which zone the asset is in, and then more importantly, if the beacon leaves the work area, you can trigger an alert and send a message over LoRaWAN for management. And the way that's going to work is that they have a timestamp and there's cameras pointed at the work area, but currently if the tool goes missing, not knowing when the tool has left means that the cameras aren't super useful. So progress I've currently made. Currently, I've managed to receive packets for receive the advertising packets with the TTGo T-beam base station, and I can estimate the distance reasonably accurately, sort of, within meters of accuracy using the RSSI values. And then what I'm currently working on is sort of the interaction between the receivers, and I've just had a chat about controlling sort of where the zones are using waveguides. So that's probably 2 minutes. So thank you very much for listening. If you have any sort of feedback or advice for me, I'd really appreciate it. My email is at the bottom.
Cool, thanks for that. Yeah, I think all of us that have worked in technical things are familiar with where is my screwdriver and where is my terribly expensive testing equipment. So that's cool. Next up's Robert. Are you on there?
Hello. Hello. Yeah, I'm Robert. I've just finished my integrated masters in electronic and communications engineering. So my deal was is predicting and managing waste levels in smart buildings and cities. I noticed that even on a hot day like this, in a park, the bins at this point will be overflowing, and that's something that it seems like it will be quite easy to predict. So a number of factors, you would just need to sense a number of things. Like one thing I'm currently sensing in my own home is movement of people, with my family's consent. That's what I'm doing, and I've currently made some sensor nodes out of widely available ESP microcontrollers and some widely available sensors that I just ordered up from Amazon. I'm using a Raspberry Pi as a server, and getting and on that Raspberry Pi is Influx and Grafana, like the other interns are running, and so I do have that time series data that's all running on Wi-Fi with an MQTT broker. With a smart building, that is an ideal solution to run all of the sensors on the Wi-Fi, and being in the building, they can all be wired as well, so you don't need to worry about having to do things wirelessly. However, that is one of the things I want to move into next, doing wireless sensors, which would be necessary for outdoors, and the microcontrollers that I'm working with, that's completely viable. And so the next step for me is doing some analyzing all of that time series data, and also starting to communicate with LoRa, sending data to the network and receiving data from the network. Because if you consider in a smart building, you would not only sending data over the Wi-Fi is obviously very useful, but getting data from the LoRaWAN network would also contribute to the analytics. Okay, thank you. That's all from me. I look forward to hearing all the other speakers. If you've got any questions, please put them in the section. Thank you.
Thanks for that, Robert. Right, next up is one of our first pairings, but I think it's Kennedy that's speaking, which is good because it means I don't have to mispronounce Onyaka's name again. Are you there?
Yeah, can you hear me?
Yeah, go for it.
Okay, yeah. So hello everyone. I'm Kennedy. I'm a second-year student studying robotics and mechatronics engineering, and I'm working with my partner Ioetec, who is also a second-year student, but he's studying avionics and controls. Now, we're working on a project we'd like to refer to as an RFID tag reader as a LoRaWAN application, and we're working on this project in collaboration with TeamSlippage. Now, a brief overview of what our device is. So our device reads RFID tags information and sends this information over LoRaWAN to a user who is probably the manager, the employer, or anyone that is required to see the information. Now, each tag has a unique identifier that differentiates each employee from another. Now, some components required to make the system include the Arduino, the RFID tags, the RFID readers, ThinkUno, and other related LoRaWAN devices. The applications of this project is quite vast, but for this project, our test case is an alarm system. This alarm system notifies the managers or the employers when someone clocks in outside office hours, and it's going to serve as a distress system to notify the ambulance and the rest of the building when someone gets injured. Other applications of this project includes attendance monitoring to know who and when someone clocks into the office. Then for machine security, in some offices, there are some machines that are quite hazardous and require specific qualified personnel to operate them. So it's quite important that you actually know who turns on the machines and who uses it in order to ensure safety. And this RFID tag reader will serve a very good purpose here, as each employee has a unique identifier with the tag. So it's quite a very useful application here. Then, in general, the RFID tag reader is quite a good application in anything that has to do with accountability. So you know who actually does something and when they do it. So yeah, that's about time. Any questions? Welcome.
Thanks for that. I think the lone working test case is a lot more relevant all of a sudden, isn't it, with the COVID restrictions, etc.
Yeah.
Mark, are you on there? Do you want to compare the question?
Yeah, thanks, Ramsay. Yeah, some really interesting projects coming out from these guys. Yeah, well, there's one each here by the looks of it. So from Matthew, for Tom, how are you getting on with the Bluetooth insistence on using server and client the long way round?
The beacons aren't actually considered a client. They're I think peripheral. So it's not, I can sort of tie this into the other question actually. There's no encryption at all. It's just saying, hello, I'm a Bluetooth device, I'm here, and then anything can see that. There's no authentication between the gateway and the beacon.
Okay, thank you. And from Kevin then, this is a good question, Robert. Do you know the potential savings by directing waste collection based on need? So as the bins get full, rather than periodically, either they keep on going around in a circuit, as is the norm at the moment. That's a really interesting question, because it comes down to the cost savings, and this is the thing that sells IoT products. Is the value that you're going to be selling to, as use the example that you're using for public services. So have you any idea or indication or looked into that?
In terms of the number of pounds and pence, unfortunately, I do not have an answer to that, but I really should. But what I can say is that you certainly reduce incidents of things of overflowing bins, because once you get rubbish on a green space, or once a collection service breaks down, then the amount of extra labor required to fix that is going to be enormous.
I also guess that the data you're getting from it shows the more active bins, so that you put either more bins in that location, or you just do more collections for that particular area. I suppose it becomes a bit of a predictive collection then. Yes,
it would be a predictive collection, and more bins is another solution. Well, what you can do is one response you might have to the data is, instead of we need to collect them more, you might think we need to put more bins there, and then you don't need to collect as often.
Yeah, okay. And Mike, he asked Kennedy, is there any confidentiality issue with identifying people in the application that you're producing?
Well, I'm not really sure I do understand the question, but in Tinsley Bridge, as we're made to believe, every employee has a key fob that emits a radio frequency which the RFID tag readers read. So I don't think there's any confidentiality issue, because every employee has a unique identifier with the key fob. So
okay. Have you considered security in your application, or incorporating security into it?
Well, we haven't really gone into that currently, but that's something we'll look to as the project goes on.
It's great to see Tinsley Bridge offering so many test bed availability for these students as well. So I think Alex is on today. So thanks to Tinsley Bridge for providing the environment in which these students can roll out and test bed their stuff. Okay, well, thanks for that, guys. We're going to move on now to, bang on time, 6:20, to our next guest speaker, Jonathan Bray, Deputy Head then of Digital at the University of AMRC, and to talk about the ventilator challenge that I'm sure we're all well aware of, that was set up a few months ago. So, Jonathan, hopefully our connection is more robust now, and you're good to go.
Hi, Mark. Yes, let's hope it is. Hello, everybody. Yeah, so hi there. Yeah. Hello, everyone. So what I'm going to talk about tonight is really the technologies that we had at the AMRC that we were already demonstrating, and how when the call to arms, you could say, came to industry, that we were able to just deploy it at speed because of the need and the want to now. So if we go through the slides, I'll be able to show you that the main 3 technologies that we actually used. Who's driving? There we go. Okay, so what we're going to look at today is how we used augmented reality. So something that we're all aware of, and we've all seen it sort of at home, through gaming or sort of on not at scale within industry itself. How we used some automated guided vehicles, AGVs, to look for social distancing, and then how we were able to simulate this and to actually look about the factory setups themselves, and how we were able to sort of repurpose and reconfigure factories as well to produce products that were totally different to the norm of what that facility was normally making. So we can go to the next slide, please. Okay. What we got here is we were using the reality headset from Microsoft HoloLens, and using that with PTC's expert capture, we were able to go to the main site and actually record what would have been the sort of the golden standard of the assembly of the ventilator, and then from there, then we were actually able to create work instructions and training guides that allowed us then to be able to roll it out across several sites across the UK. Now, including GKN, Ford, and Airbus. It was really useful in the fact that it allowed the main ventilator manufacturers to actually not just train at distance, but also to be able to sign off as well that the engineer was actually capable to actually make to actually assemble the ventilators, because you had to show that you were able to actually carry out these skills, so what we were able to do then is to get I think it's we had about 100 of these HoloLenses delivered to my head of digital's home, and Rob Scott he configured all these with the help of 1 or 2 of the engineers from the AMRC, and actually distributed them across the UK. So for me, this really showed that you were able to take a technology, and actually when the want was there, to actually to actually do the work and to roll it and to use it at scale as well. And that was really one of the big benefits that we had from that, and it allowed us to be able to ramp up quickly and to go on to make, I think, nearly 10,000 ventilators with that. So the use of and now from the use of using augmented reality within this environment has actually now changed the mindset of manufacturing to say, well, we can actually use it. There is now we can see a business case for it. It's no longer something that sort of one engineer in a department has as a keen eye to try and roll this out, and is trying to prove what the business case is. We can actually see what it is. We don't need to procrastinate why we need to do it now. We've actually got real business cases now to show the benefits that it's had as well. And you can see in the 2 pictures there that I put, that we've got one of the guys up at from Airbus up at AMRC Wales at our site there using it. And then again, you can see what he's actually on the right there. You can actually see what the engineer would actually be seeing themselves. So you can actually get you can actually see your work instructions and actually click through them stage by stage, and actually record, and also record that you've completed that stage correctly as well, and therefore, you know, not allowing you to move on if you haven't completed something, because all that is built in to those digital work instructions. Move on to the next one. Okay, so this was something where we were called up by Mercedes to say, look, you know, we've got 1 or 2 little AGVs already here that are doing some work, but you know, what have you got? Can you come and help us? Because, you know, down at Mercedes AMG, they were building the CPAP devices, and they were very keen to keep that social distancing, and obviously that time of the pandemic we had, you know, very strict. So within 24 hours of being asked of Mercedes, we were able to actually deliver 2 of these MER AGVs that we had on site down there, and actually deploy them. And within that time period, then they were covering over three shift patterns, and you can see they, you know, 20K a day. But again, it was allowing the operator to stay safe at their workspace, and to actually to assemble the CPAP devices, or the part of the CPAP device that they needed to do, and then the AGV, then automated guided vehicle, would take it to the next station. So therefore, not only keeping social distancing, but also keeping it very efficient in the fact that you haven't got operators just wandering around, you know, trying where's the next stage you need to go to, and you can also schedule it as well, so everything, you know, follows that tack time of what you needed to do to meet that. So that was a real success as well. And again, as I'm talking about, it was a technology we already had at the AMRC. It was a technology that we were already demonstrating for other large manufacturers. But you know, again, it just showed that we needed to implement it, and we went ahead and did it with really, you know, no big problems within doing it, and it was very successful. Move to the next slide. Okay, so what you see here is this one of the setups that we had up at AMRC Wales. Really, what we wanted to be able to do is to look at how we could, you know, we could simulate beforehand what was the best route, what was that factory needed to look like, and by using discrete event simulation, which is really, you know, taking, you know, what we had there, a model, taking the visual of the factory setup, and just running, you know, lots of what if scenarios to show, you know, we need to make X amount of betas in this time frame. How are we going to do it? And then how are we going to do it by within the safest parameters? You know, we need to have, you know, one-way systems. We need to have distancing between workstations. Again, we need to have, you know, where's the technology going to go? How are we going to lay all this out? And by doing that, then we were actually able to sort of to minimize then the sort of the human interface in between people, because we sort of worked it all out first of all very quickly, and then within the Airbus AMRC facility, we were able to you know, with Siemens, create this pop-up factory, which again went on to create many ventilators. And this is you know, very prevalent now going forward, where a lot of businesses are actually seeing, even if they're a legacy facility, you know, that we can actually scan as well a facility to pull in that data and create a model of it, and actually start to understand then where things can be moved around, and you know, where bottlenecks might be. So you sort of you know, you can sort of do all your, what would be sort of your Kaizen project, you know, Kaizen work. You'll be able to do that digitally now, and you'll be able to, you know, you can see where the flow and everything is. And discrete event simulation, or DES, is something that we do a lot at the AMRC, and it's very favourable. Again, many of the other things that we did with the machining group, we actually produced many parts. So we actually machined a lot of test parts initially, so that went up. Our design group, we've got a very large 3D print additive manufacturing center, and through the use of the tools there, we would be able to create a pop-up maker center, which we then, you know, we 3D printed face masks and distributed them across the region. So there was thousands of those done. But really coming out of all this, and this is my point, is we had these technologies, we're demonstrating how these technologies can be adopted. We're trying to accelerate the adoption of these technologies into manufacturing. And now the manufacturers are actually, as I said in the initial slides, that manufacturers can see that there is now a business case for these. And really it's from the, coming out of the emergency response, how we're now moving on to sort of the industrial support going forwards, and businesses now coming to us and saying, well, we've seen what you're doing, we can now see a benefit for that. How can we do that? And even around where that, businesses, if you look at GKN, what we have in there, we had GKN, Airbus, 2 aerospace companies, we had Ford, automotive manufacturer, suddenly repurposing and reconfiguring their factories to produce products that were totally different to their norm. And that was always one, that's always one thing that we get asked when people, these large car companies or aerospace, is how can we improve our changeover times from one product to another? How do we do that? And and now we can actually show, again, through what we've done with the ventilator challenge, that you can not just change over times from one product to another product within your sector, you could say, but actually the ability to completely switch over if we need to, and showing the digital tools we have. So if you want to know more as well, there's more detail out there on the web, Mark, and I'm more than happy to get in touch with me as well, just to talk about and how they can sort of look to implement some of these technologies going forward.
Oh, that's great, John, and thanks ever so much for that. I mean, 2 things there. If ever there was a great illustration of the necessity being the mother of invention, that was certainly it, and also a great illustration of agile manufacturing, how quickly manufacturers can turn around, as you said in your closing comments then, completely turn their production process around to do something else. Few questions for you, John, then from Kevin then. Is anyone commercializing the discrete event simulation to make it accessible to industry?
Well, the DES work that we do is already, it's off tool sets that you can already get from some of the large tech companies. So it's already been out there. It's already being used. When I worked at Airbus, let's see, over 15 years ago, we were using it there when we were looking for A320 wing build rate. How do you go from 20 wing sets a month to what they're trying to get now to 60 wing sets? And it's just it's improved over the years. And it depends whether you want that information spat out to you within a spreadsheet, or whether you want a nice graphic to show you where exactly all the issues are. But yeah, that technology is there, and it's readily available for demonstration at the AMRC as well.
Oh, great! Again, people would just contact you to find that.
Kerry, yes. My details there.
Yeah, great, thank you. Kerry asks, what opportunities do you see now for digital meeting manufacturing in the Sheffield region? Is this now enhanced? Is that is what you've done over the last few months sort of opened up as a more of a showcase than it already is, and attracting interest now?
Yes, I mean, one of the things that I've been really driving, I would say, over the last 18 months is introducing digital businesses to manufacturing businesses on 2 levels. One, to get manufacturers to realize that there is, it's easy to actually implement some of these technologies. I say easy, you do it in sort of small steps, but it's not the big blinded, it's not a big blinded challenge if they do it with the right businesses. And also I've been talking to digital businesses that aren't necessarily in manufacturing, but have the skill sets and the capacity to actually support manufacturing going forwards. And I think now this is a time now where we do need to start looking at how manufacturing adopts digital technologies. How do we get them to do it quickly? To gain the benefits that from it, whether that's as the student showed there, whether it's capturing data and for people within the businesses to understand the value of that data, and whether that's air quality, you know, from outside of your building coming into your building, or whether it's monitoring where people are within a business. If your machine is, you know, predictive maintenance, is your machine going to break down? Predict when is it going to break down? Well, in that case, let's look about, you know, not just send that information to an ops manager. You know, let's cut the ops manager out and send it straight to procurement. You know, I'm a real advocate of connecting the shop floor to the top floor. You know, that if that data that you're collecting is so valuable, then it needs to be, you know, disseminated across all the different departments, because obviously, you know, it has big benefits. And again, there's many digital businesses across the Sheffield City region that have a, you know, a place to play in it, whether it's, you know, a consultancy role of going into a business and horizon scanning of what the issues are, whether it's taking somebody, you know, from using Lotus up onto 365, you know, take them onto the cloud. You know, there's so many opportunities there that, you know, outside of just going into a business and saying, let's put some sensors on a machine and let's take the data off it, you know.
Yeah, for sure. And have you seen evidence of these becoming permanent solutions in these applications?
Well, I got to say, due to the lockdown, and we're not actually fully open to visitors yet, then you know, I haven't as such, you know, because we're only just coming out of using all these ourselves. So really, only the business cases, and you could see the promotion of those business cases are really sort of coming out there into the media. And if you follow the AMRC on you know, our various social media channels, you'll be able to see all the good work that we're doing and who we're doing it with. When, you know, obviously, depending on what we're allowed to show and what we're allowed to talk about, but it will, I mean, it will definitely come out. We did a piece tonight on it. And my head of digital, Rob Scott, you know, there's a bit there saying that because of the Ventilator challenge now, the take up of augmented reality now will be much greater going forward.
Yeah, for sure. And Johnny asked, final question: do you see a potential in utilising artificial intelligence and machine learning in the discrete event simulation?
That again, the discrete event simulation runs on a lot of, you know, you enter in your parameters of your what if scenarios. From my background in my previous life, you know, we went to set up a factory using a lot of sort of manufacturing engineers, you know, fingers in the air sort of values. And when we actually went ahead and ran it through an event simulation, that we came to the conclusion that they were totally wrong. And then obviously, you know, if you're starting to then, you know, apply machine learning into that, then, you know, the more data that you collect, then obviously, you know, the more data sets you collect, then the better that machine learning can be. So if you really, you know, if you look at discrete event simulation, it's more snapshot of time than maybe what we might prefer to then as going into digital twin, which would be a connected live system. So if you really want to take your DES simulation and then connect that to your IoT devices and start pulling in that information then into that into that live simulation, and start using machine learning to then predict, you know, failure in your line, predict bottlenecks, predict you know, when you might need to, when is the best time to do a changeover. Are you shift, you know, one of the things we've done with it a lot is we did it with a balloon factory that is identifying what are the correct shift patterns, you know, so you could find, are you actually running the right shift patterns, and do you have the right amount of staff to be running in your factory? So you know, there is obviously, you know, AI machine learning, there's a lot of opportunities for that in manufacturing going forwards right across the board.
Great. Thanks, John. And I know John, working closely with John previously, he's a keen proponent of any supporting anybody. So if you do have any questions, there's his contact details on the screen. And I know he'll get back to you and support anything that, any help that you might need. So thanks, John, for coming on today. Appreciate it.
No problem, Mark. And again, you know, I'm on LinkedIn as well. If anybody wants to send, you know, connect up and send me something through there as well. Not a problem.
Any idea when the AMRC is going to be
I'm still working from home, and at the minute the only people we've got in there are working on project, on must projects. So it's all phased, and as we are the university, then obviously we are working to the university protocols as well.
Yeah, sure. Well, hopefully you'll get up and running properly soon. But thanks once again. If you do get an opportunity, go visit out of John's office. He has one of the best offices in the world. So do definitely get a chance if you have the opportunity to go out there and visit.
Thanks, Mark. John. No problem.
Okay. So we're on to the final three, not the least, but certainly the next three candidates from the Pitch in IoT students. So Ramsay, over to you.
Yeah, thanks. So I mean, I think our last three are clustered vaguely on being more manufacturing related. First up is another of our long distance correspondents, Amar. Which country are you in this week? Are you there?
Yeah. Hi, can you hear me?
Yeah, we can hear you. Go for it.
Yeah, I'm in Egypt now. Perfect. So yeah, my project is on industrial energy monitoring. So just a quick overview on my background. I'm a fourth-year student going into my final year of mechanical engineering, and I've just finished my year in industry. So my main interest in this internship to start with was the fact that I was quite excited to learn more about how you can change the power grid into a more renewable resources, and the main challenges that are facing that are usually to do with the intermittency of renewable generation. So I was excited to see the prospect that IoT has in overcoming these challenges. So in terms of manufacturing, the great thing about the steel industry is that amongst the manufacturing sectors, it's one of the most energy consuming. So there's a lot of incentive going forward to reduce its power consumption. And so per the International Energy Agency, the main recommended action going forward would be to improve its energy efficiency. And so my project's proposal was to create some sort of IoT-based framework for a case study of a steel manufacturing facility that has its own solar farm to create a demand response energy management scheme. And so the framework can be split into four main actions, and that is to measure the power with sensors, transmitting it over LoRaWAN, and then arranging that data into a database and visualizing it on a dashboard. So far, I've done the latter part of the project, mainly because of the issues we've had with getting hardware. So by getting in touch with Alex from Tinsley Bridge, I was able to find power consumption data for the manufacturing facility over a month. And by getting some open source data about solar generation, I could match that data to meet the net demand of the factory throughout the month. And finally, finding data about the selling and buying costs of power to the grid, you can then determine how much it would cost throughout the month to be balancing the demand and supply of your energy. So to create the dashboard you see on the bottom left, I used Telegraph, Influx, and Grafana to import the CSV data I had and display it onto the dashboard. And the main goal of this is that a manufacturing facility can, at a low cost, set up some sensors to try and quickly visualize how, or like which regions throughout the day or throughout the year, where it can perhaps change its consumption to best exploit the variations in price set by the national grid. And yeah, thank you very much.
Cool, thanks for that. Yeah, so we are shipping hardware to you, and it will be the second LoRaWAN gateway in all of Egypt, I think, won't it?
Yeah.
So that could be good. Next up, we've got Ahmed. Are you on there?
Yes, hello.
Hi, go for it.
Hello. So I'm Ahmed. I'm a third-year electronic engineering student at the University of Sheffield. And my project area is wireless temperature monitoring systems in industrial environments. So specifically, I've been looking with Tinsley Bridge, I've been looking into using LoRaWAN to monitor the heat dissipation within electrical panels and quench tanks and other pieces of machinery throughout their site. This can be used to predict possible thermal issues and maintain them, which may lead to an improved overall efficiency of their systems. So current wired technology requires high installation and maintenance costs, as well as limitations on where you can place these sensors throughout the site, which are all disregarded when you use wireless technology. So there are other applications for this, which include more precise manufacturing processes, such as alloy melting or monitoring the energy consumption within large data centers. Currently, I've set up an MQTT server where the temperature data is being published onto it using an ESP Wi-Fi module so that I can work on the database management and dashboard display on Grafana. So I will be using LoRaWAN instead of Wi-Fi, mainly because of its longer range capabilities, and the sending over temperature data doesn't really require the high bandwidth that Wi-Fi provides, and this can lead to lower overall power consumption and possibly using battery powered sensors, which can be more flexible. So thank you. If you have any questions, please let me know.
Well, thanks for that one. And our very final presenter is our other team of two, but I think we've got Harrison is doing the talking today. Are you there?
Hello, can you hear me?
Yeah, go for it.
Okay, cool. So I'm Harrison, and I'm also working with Nathan, but I'm doing the speaking for this one. And so we're both computer science students going into our final year of integrated masters. And we're kind of both passionate about IoT, but also kind of interested in the data science type of things. And so our project is working with AMRC with some work that they've kind of already been doing to retrofit kind of legacy manufacturing equipment like old lathes and pillar drills and things with sensors. And so kind of the aim of that is to do, a little bit of like live monitoring and some predictive maintenance that we hope to be able to get onto in the few weeks that we have left. And so while kind of AMRC have done some work on this already, we're kind of looking at the possibility of whether this can be improved with a private LoRa network within AMRC, mostly because it is just a better fit for the kind of data that's being sent, as well as kind of making some security issues a little bit easier. So far, we've fortunately got our hardware like 2 days ago, so some of these slides are slightly out of date now because we've been able to do some more things. But we've kind of got some very basic sensor data coming in from a LoRa node, going through just the public things network for now to a Node.js server, which sends that off to InfluxDB and gives us some Grafana dashboards that now kind of give us some live temperature data, which is nice. So ours is kind of set up from end to end. We had some like kind of initial challenges with deciding on kind of what the appropriate technologies are, because as Ramsay said earlier, a big part of this project is solving problems for anyone else that might want to do this in the future. So we kind of wanted to pick things that would be both scalable but also easy to use and doesn't involve loads of boilerplate code and is fairly easy to modify afterwards. So we've had to consider both our own use and anyone else. And we've also been trying to make a lot of our work applicable to a lot of the other interns on the project. Like we've got some stuff on the GitHub that other people have been interested in stealing from us that solves some of the problems so far. And kind of going forward, we're looking to focus a little bit more on security, which is quite important for lots of these things where you're sticking sensors in a manufacturing plant, as well as kind of looking towards doing some like unsupervised learning or clustering with the data if we get time to look at doing some rudimentary predictive maintenance. But yeah, so thanks for listening.
Cool, thanks for that. So there seems to be a couple of questions for Amar. Mark, are you going to compare again?
No, you go right ahead.
Yes, I suppose I might as well. Yeah, Amar, are you still there? I think Mike is just asking you, firstly, are there some applications for this in domestic environments as well as industry ones?
Yeah, actually, when I was first researching this, almost all of the applications were domestic. So it's usually people tinkering around with sensors and Arduino boards to try and get to try and monitor their energy usage in their house. So I guess the challenge going forward with this is industrializing it, if that's a word, to try and just use the same cheap technologies within an industrial setting. So to answer the question, there are domestic applications.
The next question was whether you see any challenges testing your solution when there's only 2 gateways in Egypt. Of course, one of the gateways will be in your living room once we get it to you, though. So, but more broadly, I mean, it's interesting whether these things can be rolled out in places where there's not the infrastructure yet.
Yeah. I'm not sure how it's going to go because it would be my first time tinkering around with gateways. But in terms of the data itself, it's good that I already managed to get some data for now that it's not using any sensors, so that's good. But if this project would be to implemented fully in Egypt, it might be a bit challenging. But I assume once you get one of them set up and running,
these things can work both ways, I guess. Once there's some applications, then there's a push to do the infrastructure. I know Mike Faulkner's favorite joke was always that, you know, selling the second phone was easy. Who on earth bought the first phone ever?
Exactly.
Once there's something to do, you put it in. Ahmed, if you're still there, Mike Fawkes is just asking whether you've got any data yet and on what kind of battery life you might get out of these things.
I'm not sure on how much exactly these sensors would last, but it really depends on the type of end nodes you use as well, and if they have more than one sensor on board, and if those are turned on, because some of them come off the shelf with many different sensors, which are hard to turn off. So not sure exactly how long, but it has a much higher battery life than if we were to use Wi-Fi.
Sure, no, absolutely. And something to look into for the next few weeks, your project. Harrison, if you're still on. Yeah, so
I'm still here.
asking about kind of, have you thought about making your solution rugged given the environment you're going to be sticking things in?
Yeah, I think that's a good question. It's currently not something we've put much thought towards, having kind of only just got our hardware a couple of days ago. But it's something we'll want to look at, especially when we start kind of doing slightly more custom things. I suppose the bigger thing is probably looking more at where exactly you're going to put temperature probes and things like that, and making sure they're in places where they're not going to fall off. But I do think it's something important to think about, especially for something that's going to be there long term.
Yeah, and sort of hostile environments and so on. But again, something to keep thinking about.
Just can I interject, Ramsay, and ask Harrison while he's on the line, are you looking at private or public LoRa network, Harrison?
We're looking at private ones, just because this is kind of a big discussion we've been having with Mike around security, and I know he's quite interested in our project. And I know kind of with AMRC and the way that all of their IT systems are set up, and just for general security, having a private network makes a lot of these security issues easier, and trying to do good security on devices that don't necessarily have a lot of processing power and aren't necessarily able to do, you know, world's best encryption does make a lot of that much easier. But yeah, overall, it's something we're going to be looking more at in the next couple of weeks now that we've got some basic things working.
Okay, and a question from Kevin, and it's to all of you: has been participating in this project encouraged you or got you interested in going into manufacturing after you graduated? That's an open question to any of you.
Yeah, well, I'm more interested in the data acquisition and processing so really, yeah, I am interested in working in manufacturing, and learning on how you can improve overall efficiency in such industrial environments.
I think that brings up a point that I would make, certainly as the person who's got to teach these engineers. I mean, I didn't mention it, but you might have noticed they've come from all sorts of different engineering departments. They're not all software engineers. And yet all of them are ending up doing IoT type stuff. And I think that's one of the really interesting things for teaching engineering as well as for practicing it is you might think you're doing mech eng so you can go into industry, but you're going to end up doing some software and electronics. And similarly, the aerospace engineers and similarly our computer scientists are having to deal with all this manufacturing and industry things. The really kind of multidisciplinary nature of all of the businesses is kind of really impacting these students. And these guys are getting a really great head start at it, I think. So. I think we're back to you now, Mark. I think we've done our bit, although we're all still very much around, and if it's not been made obvious, these students have got another 4 weeks of funding. So if anyone's got any brilliant ideas to work in the next 4 weeks, please let us know.
Yeah, sure. Just final couple of questions then. One from Alex is, which private LoRa network are you looking at, Harrison?
So currently we're just looking at setting up our own. That's kind of the idea of keeping everything in a closed loop. So having our own gateways and trying to just forward that onto like a local like node server is the eventual plan. Okay. How possible it is or how that's going to work, you know, is yet to be seen. But that's the current plan.
And from John, do you see the way engineering and computer science changing? This is the sort of the next generation of engineer. Will you see engineering and computer science changing in the near future? As things change, engineers need to get a little bit more rounded rather than being a specialist in a particular niche area. That maybe that should be towards to yourself, Ramsay.
Yeah, no, I mean, I can talk about that for months and months. Actually, I'll be very curious to see what these students think by the end of the course, because again, they've done, most of them have done 2 or 3 years of engineering degrees, and some of our engineering degrees are teaching good old-fashioned classical engineering, and some of the bits are very sort of forward-looking, and I think a bit of both is necessary, but certainly the days where you can have the kind of, oh, my code's awful, but that's okay because I'm a mechanical engineer, are hopefully behind us, and vice versa, the days where our computing students can get a job writing spreadsheet applications or something just on a desktop are also well behind us. A bit of at least knowledge and appreciation for each other is going to be important, even if not like detailed skill.
Yeah, sure. Great. Thank you, Ramsay, and thank you to all the students. And we're looking forward to next month when we're going to hear a further progress report them in our next summer IoT meetup. So I wish them all well now. They've progressively getting all their hardware, and we hopefully they'll see a massive leap forward in the next 4 weeks. Okay, we're running a little bit behind. That was an interesting session, but we're going to go on now to Kevin Hallis. Kevin is a massive proponent of supporting innovators and manufacturers co-collaborate and co-create stuff. And he's going to talk about what KTN and Innovate UK are doing as far as manufacturing made smart is concerned. So, Kevin, thank you, and it's over to you.
Yeah, thanks, Mark. Can you hear okay? I'll assume you can if you don't interrupt. So Kevin Hallis from the manufacturing team at KTN, Knowledge Transfer Network. So I'm here really to talk about the Industrial Strategy Challenge Fund and the Manufacturing Made Smarter part of that. So about digitising manufacturing. So this really stems from the Made Smarter review in 2017. Jürgen Meyer, then chief exec at Siemens, said that British manufacturing should improve productivity through adoption of digital technology, upskilling industrial workers, innovation in terms of there's an opportunity here to develop new technology and to be a leading nation in developing that technology, and also around leadership. And it's really this innovation piece in the middle that Innovate UK is interested in, and that's where the ISCF challenge fits in. So there's 2 competitions live at the moment. They are closely related. So they're both around digital supply chain. one for feasibility studies, which is obviously sort of earlier stage stuff, and then one for industrial research, sort of looking more towards the deployment end of developing solutions. You can see on the slide the details are slightly different, so the amount of money, the contribution you would get to your R&D costs, and the timescales. But just to highlight, there's pretty significant funding in this competition. Find the next one. So the aim, this is sort of direct from Innovate, is to encourage the use of digital to enable more efficient, productive, flexible, resilient, and sustainable manufacturing supply chain. So it is constrained to manufacturing supply chain. So if you're doing IoT for other things, this isn't for you, unless you can see how you can apply it into manufacturing. Yeah, and Innovate will balance the portfolio that they fund. So there's a, you know, won't end up funding dozens of very, very similar projects. It's just a bit of a caveat for them to manipulate. Next slide. I thought if you're not used to Innovate and some of this applying for funding stuff, it might be useful to give you some idea what a project might look like. So, and this is kind of my views. I've tried to interpret what's come out from Innovate and from what we know about the discussions. So there is certainly going to be a digital technology innovator in every project, because really that is where you're going to be developing the IP. It must include at least one manufacturer, and it seems to me that an existing customer is potentially quite a good collaborator to think about, like, what's the next generation of your niche. And in this competition, it also has to include another firm in their supply chain, so either somebody buying to them or their ultimate customer, perhaps. And so it's about how can you use the technology to improve the way those companies behave together in that supply chain. SME involvement would be great. I think a lot of the technology providers might tend to SMEs, but what about SME manufacturers? And given the scale of the competition, then maybe you need several SMEs involved to make it bigger and interesting and prove that it's something scalable. You know, so what about a manufacturer and all of their suppliers, for instance? RTOs can be involved, so AMRC, obviously John's on the call. I'm sure he'll be very, very keen to talk to you about potential projects. And I guess if you do make it really complex, you'll have to convince Innovate that you can project manage this. So that might be another area where you need a bit of collaboration. We're actually running a workshop tomorrow, and I pinched some of the prompt questions for the workshop tomorrow. So, you know, you really, to get this project together, you're going to need the manufacturer to be able to articulate supply issues, problems in the supply chain, things that it looks feasible to fix with digital. Given this is about innovation, it is about doing something that's not easily possible already. So Jan Godsall talks about supply chain competition in that, like, the whole supply chain is competing with the next whole supply chain. So what could we do within that supply chain to be more competitive? What problems do you have with suppliers? You know, can you build up a problem statement that helps you to then demonstrate the need for the innovation? You could talk to customers about what's soaking up time in terms of supply chain coordination. I imagine there is a lot of exporting from systems, translating in Excel and then emailing things to each other that potentially in the background could be happening. You know, what's the potential for IoT to enable the ultimate customer to see what's going on in the factory down the supply chain? You know, and would that give you confidence for decision making, for instance, that you don't have at the moment? You know, how does it affect trust? Could that be enhanced through some of these projects? So you need to think probably quite big in some senses, but not necessarily just think about massive companies doing this. And then, you know, what's the current national agenda? This is pretty obvious, I guess, but when Made Smarter was done, it was all about productivity, and since then, sustainability has become much more prominent. I guess through Extinction Rebellion, climate crisis, the government's commitment to net zero. COVID has manifested, I guess, in terms of resilience and recovery. There's some kind of political discourse, I guess, about reshoring. And certainly it's interesting to see the work that Jonathan's teams have done on ventilators, for instance, and high value items like that being manufactured in the UK makes a lot of sense. And you know, so there's a build back better agenda in terms of economic recovery from COVID. You know, where does that fit into your thinking on these kind of projects? That was what I was going to say on the project. So KTN is here to help you access this kind of funding in terms of helping you build a consortia, helping you understand and I guess challenging your ideas around the market, being a critical friend, if you like, in that process. We've got sector and technology experts who can support you with that, and you know, I'm manufacturing sort of quite broadly. So very happy to have a conversation for the event. If anybody wants to get in touch, there's my email there. I'm on LinkedIn. So yeah, that was the pitch for the funding. Happy to take any questions.
That's great. Okay. Just picking up on something you said about there being a workshop tomorrow. Is that an open workshop or is that a closed set?
The registration may well have closed by now, given that it's gone 7 on the day before.
Yeah.
Yeah, you might have missed that one.
No worry, no worry. I can wholeheartedly support Kevin in what he's saying about the support that both he and the KTN team do. We've made has helped us and also garnered the support of various colleagues he has and specialists in the area. The Innovate grant process is quite a lengthy one, but well worth it. And I can say that, and Mike will tell me off for letting everybody know prematurely for tomorrow that we've been successful in getting an Innovate grant, and we were notified that at last week's, and we're just about to press release that tomorrow. Yeah. Grant application, and we finally have got there, so we're very pleased as Ioetec, and we're part of a nice consortium. And to echo some of the points that Kevin said, is it's really important to have a great collaborative team, both from an academic point of view, an industrial point of view, an end user point of view, and then you have the SME. So yeah, it does work, and we eventually got there. And thanks for all the congratulations, appreciate it.
Very good.
Yeah, any questions for Kevin? As I say, he's a very keen proponent of KTN and all the work they do and Innovate. Is there any questions for him?
So I can see that Kerry has asked.
Yeah, I got there. Yeah, so for Kerry, from Kerry, then for Kevin, is this effectively the national rollout of the Northwest Made Smarter pilot, or will that happen also widely?
So no, it's definitely not. So the Northwest pilot is very much about adoption, and it's grants for businesses to go buy something off the shelf, basically. And there's also some training elements to it. That will be rolled out by BAYES rather than Innovate because it's business support, and it will be subject to getting funding from the spending review. So it's interesting that you mention it, because at the moment you can go on .gov website and contribute your thinking to what should be prioritised in the spending review. So if you want to go in there and say that digital and manufacturing is really important and it should be supported, then you can add your weight to that argument. But yeah, so it's
okay.
This is innovation, not more of what we've already got.
Sure. Just going back to the workshop, the briefing event's been recorded and available, or is it
Yes,
is it close to?
Briefing event is available. I've got a link to paste in the chat now. You remind me. So I'll put a link in the chat.
Thank you for that. All right, great. Thanks, Kevin. And can I thank everybody who's spoken tonight, from both John, Tom, who's no longer with us, and Kevin. Thank you so much for your input. Really very interesting and great to see the support infrastructure that's in our region that is there to help innovators. And the best of luck to all 9 students who pitched today. And we really look forward to their see how much more they progress. I'm just going to start wrapping up. I think I've got a couple of slides to share. I haven't done this before, so let's see if I can find what I'm supposed to be doing. Thank you. So really, this is just a final shout out. So I invite anybody to announce any information that they may have, IoT related, any events, any successes, any wishes. Feel free to pop them into the chat box, and I'll the next couple of slides tell you a couple of things. The Digital Catapult have a great IoT lab down in their offices in Houston. They've got an IoT discovery program, which is helping industry to accelerate, as you can read there, the understanding and adoption of IoT. So it's for businesses that are thinking about their digital transformation and the adoption of IoT. So there's the link for it. If you need it, contact me. Ioetec.com. I'd be very happy to pass that on if you can't find it. I haven't got time to write that down. Also, the IoT Security Foundation have got a virtual conference in December. I know it's a bit of a way away, but they are doing early bird ticket prices for the conference, virtually half price, and also rebates for students and academics. Again, if you go to that link there at the bottom left-hand side, last year's one, it's a really interesting conference and covers a lot of ground with regards to what the IoT are doing with regards to really world leading as far as doing secure by design on that. And then finally, yes, IoT number 7 part year, which will happen in a month's time on the 27th of August, same time. The Eventbrite, and Kerry has kindly put the link there in the chat. So please go ahead and register there, and we're going to have a number of speakers. Again, IoT related over innovation, and again, we're going to get an update from those 9 students to see how well they progress. So the pressure's on for them to give us some update of all of their projects at the back end. If anybody's got any, I'm just having a look and see if there's any. Here we go. There's Kevin's one saying they're putting together the Innovation Alley for the Smart Factory Expo next month. He's going to be able to say something. Again, from personal experience, I was very lucky to be invited to get a place at the Innovation Alley, which is in Liverpool at the Smart Factory Expo, and it was really worth manufacturing there. So most certainly keep an eye out for that, and hopefully Kevin will publicise that, and we'll most certainly promote it on behalf of KTN as well. So with that, I thank you all for your time. We've hit bang on 7:15, which was, I think that's the first time we've run actually to schedule. So I thank you all for coming and listening, and I hope you got something out of it today, and look forward to hearing time. Have a great summer holidays. Take care now. Bye bye.